For this video, we will be talking about section 10.3 and 10.4, which is multiplying polynomials. On the front, you will see that we are multiplying two binomials together. If you remember from 10.1, binomials are polynomials that have two terms. So looking at this, there is a process in which we are going to multiply two polynomials together, more specifically two binomials together. So I'm going to teach you three different methods, and then by the end of the front of your notes, you get to pick the method that you like the best, and then that's the method that you can do from here on out. There is one method that I will tend to go with every single time once we get there. But like I said, any of these three methods totally works, completely up to you which one you would like to do. So first example, using the distributive property, it says take the first term in the first binomial, that would be 6x, and distribute it through the second binomial. So we're going to take 6x and then distribute that to 2x plus 3. Then it says take the second term in the first binomial and distribute it through the second binomial. So then we have a negative 7 here and then times 2x plus 3. So now we have a problem that we're very used to seeing actually. We've done several of these already this chapter. So then I'm going to take 6x and distribute that to 2x and to 3. 6x times 2x would give me 12x squared, and then 6x times 3 would give me plus 18x. And then we have negative 7 times 2x would give me a negative 14x, and then negative 7 times 3 would give me negative 21. Then after this, we still have two things that we have to double check. We have to combine any like terms that we can, and then we also have to make sure our answer is in standard form. So looking at this, I see that I can combine these two terms right here, 18x and negative 14x. So then I'm going to bring down that 12x squared because, again, we have to keep it in standard form. And then 18x and negative 14x would make a positive 4x here, and then bring down that minus 21. This would be our final answer for that problem. So then looking at number 2, same process here, using the distributive property. I'm going to take 9x and distribute that to the second parenthesis. So then I have 9x and then times 7x plus 4. And then we're going to take negative 8 here and distribute it. So then we have minus 8 times 7x plus 4. And then again, we're just distributing here. So 9x times 7x would be 63x squared. And then 9x times 4 would be plus 36x. And then negative 8 times 7x would be negative 56x. And then negative 8 times 4 would be minus 32. And then again, combine any like terms. I see I can combine the 2 in the middle. Again, just my x's. So then I'm going to bring 63x squared down. That doesn't combine with anything. And then if I combine my like terms there, I get negative 20 or minus 20x. And then bring down that minus 32. This would be our final answer. So that is it for the first method using the distributive property. I will tell you this is not my favorite method. In my opinion, this is showing a lot of work, a lot of extra writing, if you will. So like I said, it's going to be completely up to you. Some people do prefer that first method, so that's why we show it, but that typically is not one that's generally chosen. The two that get chosen the most are the tables that we're going to talk about right now, and then that FOIL method down below. So using a table, you'll notice right here, they took the first binomial and they put x right here and negative 3 right here, and then they took 4x minus 5 and put 4x here, minus 5 here, or negative 5 here. So that's how the table is set up. Then after that, if you have done Punnett squares in science by any chance, this might look a little familiar to you. So what we're going to do is we're going to multiply the things that end up intersecting here. So x times 4x would give us 4x squared. Then we have 4x times negative 3 would give me a negative 12x here. And then I have x times negative 5 would give me negative 5x. And then last but not least, we have a negative 3 times a negative 5 would give me a positive 15. Now, I know the arrows are maybe a little messy here, but we still have to combine like terms. We still have to make sure our answer is in standard form. So when I do this, I see a 4x squared. That's my highest degree there, that 2, the degree of 2. So I'm going to bring that one down because it doesn't combine with anything else. Then I see I have a negative 5x and a negative 12x. Those are like terms. I'm going to go ahead and combine them. So I would get negative 17x or minus 17x. and then I see just this lonesome 15 that I'm going to bring down, this would be my final answer. So that is how the table method works. Now, with that being said, let's look at number 4. We're going to go ahead and set this up first. So you'll notice nothing ever goes in this box right here. Ever, ever, ever. So then I'm going to take x and then plus 4 or just 4. If it's positive, I'm not going to put the plus sign. If it's negative, though, we do definitely have to put that sign there. So then my second binomial says 2x minus 1. Again, like I was saying, that negative definitely has to get written there. So then if we do all of our multiplying here, 2x times x would be 2x squared. 2x times 4 would give us 8x. Negative 1 times x would just be negative x or negative 1x, your choice. And then negative 1 times 4 would give me a negative 4. Then combine like terms that we can, and then also putting it in standard form. So again, starting with the highest degree of 2x squared. Then after that, I see negative x and 8x would give me plus 7x. And then bring down that minus 4. This is our final answer. Now, 5 and 6 using FOIL. So this actually is an acronym. It stands for first, outside, inside, last. This is the method that I will actually do from here on out. Whichever method you like the best, when we get to the backside of your notes, you do whatever method you like. I do want to make note really quick. The tables, I do have sheets of paper that have tables all over them. So anytime they come up on a homework assignment, you can grab that sheet of tables. Or it's very easy just to make your own. It's just a 3x3 grid. You can make your own tables on your paper. You just have to make sure if you use a separate sheet of paper to make your tables, you need to make sure that is attached to your homework because that is counting as showing your work, okay? Moving on here, going to FOIL. So again, like I was saying, this does stand for something first, outside, inside, last. I will tell you, FOIL is a faster version of the first 2 problems that we did. It's just not showing that first step. So basically what we're doing here is when we do first says multiply the first terms of each binomial. So the first term in the first binomial is 2y. The first term in the second binomial is y. So then I have 2y times y would give me 2y squared. Then we have outside, multiply the outer terms. So I always say they're the 2 that are farthest away from each other. So that would be 2y and 2. So then I distribute there. So then you can kind of see we took 2y right here and we distributed it to the second parenthesis just I got cut off. Sorry about that. We distributed it to the second parenthesis just like we did that first method. So with that being said, 2y times 2, let me get my blue pen back here. 2y times 2 would give me plus 4y. Then after that, we have the inside terms. So kind of similar to the outside, they are the 2 farthest from each other. Now we have the inside terms. So these would be the 2 that are closest together. So then we're taking negative 3 and multiplying it to y. So you'll notice I did 2 little rainbows up above. My third rainbow is going to go down below, just to try to stay a little bit neater here. Negative 3 times y would be minus 3y. And then last but not least, we have last, which says multiply the last terms of each binomial. So negative 3 is the last one in the first binomial, and 2 is the last one in the second binomial. So negative 3 times 2 would be minus 6. So again, just to go over this really quick, we took the first term and we distributed it through the second parenthesis. Then we took the second term and also distributed it through the second parenthesis. So again, a faster version of the first method that we learned. So, and then again, just like all the other methods, we do have to combine like terms. Hopefully you're kind of seeing that there's a pattern here. It always is that first degree or a degree of 1, those terms that we always end up combining together for at least these types of problems, 2 binomials being multiplied together. So I'm going to bring down that 2y squared, 4y, and negative 3y makes plus y, and then minus 6. And then on number 6, again, we're going to FOIL. So first would be 4x times 3x, which would give us 12x squared. Then we have outside. You'll also notice I'm drawing the rainbows as I multiply them. I do not draw them all 4 first and then try to figure out what to multiply. Drawing the rainbows is the way that you stay organized when you're doing these problems. So 4x times negative 6 would give me minus 24x. And then we have inside would be 2 times 3x. So plus 6x, and then last we have 2 times negative 6, which would be minus 12. Again, combine like terms, so my negative 24x and 6x are my two like terms. I'm going to bring down 12x squared. When I combine those two terms together, I get minus 18x and then minus 12. That is it for the first page of our notes. Let's go ahead and go to page 2. Okay, on to the second page of our notes here. Again, like I said earlier, if you like the tables, that's your favorite method, you can either get the sheet of paper that has the tables all over it, or you can draw your own tables on your paper. There should be plenty of room, at least on your notes, for you to do that today. So looking at the back side, these are all basically the same types of problems. They're just maybe a little bit of a difference to them. So looking at number 7, on the front side we had two parentheses for every problem, two sets of parentheses for every problem. Looking at number 7, I don't see that, but I do want to go over something with you really quick. If we think back to if we have x squared, that is the same thing as saying it's x times x. So if we have x plus 6 squared, that is the same thing as saying we have x plus 6 times itself twice. So this actually is just like the problems we were doing on the front side of your notes. My biggest pet peeve is when people think that we distribute the 2 to the x and to the 6. We do not do that. That rule that we learned from chapter 8 is the product of two things. That's when we distribute. So what I mean by that is if we had 6x squared, that is when we would distribute to both of those things. But because there is a plus sign here, our answer is not x squared plus 36. This makes me absolutely crazy. Please, please, please don't do that. So with that being said, let's go ahead and multiply x plus 6 times x plus 6. I'm actually, just because I don't want anybody to be confused, we are not distributing that 2. So I'm going to go ahead and erase that really quick. Okay, going back, I'm going to FOIL. That's my favorite method. So first would be x times x gives us x squared. Outside, x times 6 plus 6x. Inside, 6 times x, which would give us another plus 6x. And then last would be 6 times 6, which gives us plus 36. Combine like terms, my answer would be x squared plus 12x plus 36. So this literally shows you that our answer is not x squared plus 36. That there's a whole middle term that you're missing. You would be completely missing that 12x. So again, we do not distribute the exponent on this type of problem. So looking at number 8, again, we do not distribute because of that minus sign right there. So something I like to do is just cross out this 2 and I just rewrite the same exact parenthesis next to it, and then I go ahead and do my FOIL process here. So first, 7x times 7x, 7 times 7 would be 49, x times x is x squared. Outside, 7x times negative 2 would be minus 14x. Inside, negative 2 times 7x would be another minus 14x. And then last, we have negative 2 times negative 2. Don't forget, 2 negatives makes a positive here, so that would be a plus 4. And then again, combine like terms, so we have 49x squared minus 28x when we combine those like terms, and then plus 4. That would be our final answer. Okay, looking at 9 and 10, you'll notice number 9 has x plus 11 times x minus 11. So two very similar binomials, but the only difference is one is a plus sign, one's a minus sign. We're about to see what's going to happen here. So again, I'm always going to FOIL on these. X times x would give us x squared. X times negative 11 would be minus 11x. 11 times x would be plus 11x. And then last would be 11 times negative 11, which would be minus 121. When we combine our like terms, you're actually going to notice that negative 11x plus 11x actually adds up to 0x. And remember, whenever we get 0, we do not write anything for it. We just cancel them completely out. So then my answer on this one would be x squared minus 121. And that would be it on that one. Number 10 looks a little bit scarier, but I promise it's really going to be okay if we follow the same process here. Again, I'm going to FOIL. 9x times 9x would be 81x squared. 9x times negative 3y, be very careful here. 9 times negative 3 is negative 27, and then x times y would just be xy. Then we have 3y times 9x, which would be plus 27, and then again, I have y times x. I'm going to go ahead and just put them in the same order as the first term. You could put yx or xy. It means the exact same thing. And then we have 3y times negative 3y. 3 times negative 3 would be negative 9. And then y times y would give us y squared. Now, this one's going to be harder to put in, not harder to put in standard form, but actually every single term here has a degree of 2 if you think about it. Because if you remember, this is x to the first, y to the first, also x to the first, y to the first. And then when we have an x and a y side by side, so right here, that's when we would add those together. So technically 81x to the second has a degree of 2, 27xy has a degree of 2, 27xy has a degree of 2, 9y squared also has a degree of 2. So technically speaking, all of these could go in any order and it would still be considered standard form. But we are going to go ahead and just keep everything kind of in the order it's in right now. So I would have, let me switch colors here. I'm going to bring down that 81x squared. I don't have another like term that I can combine with that, but then I see that I can combine an xy term with another xy term. Those are like terms. Now, just like number 9, negative 27 and positive 27, those add up to 0 actually, so we won't have that middle term there. And then I'm going to go ahead and bring down that minus 9y squared, and that's going to be our answer for number 10. Okay. Moving on down here, number 11, what is the area of the shaded region? This problem tends to be tricky for a lot of people. So basically what we're looking at here is this is a hole. That's like an empty space there. I typically show a piece of paper that kind of visualizes this a little bit better for you. But I take a piece of paper, I cut out a rectangle in the middle of it, and then I put my face through it. So maybe you can visualize that right now. You should be able to see Mrs. Ackerley's face through that hole. Haha. Okay, so you're trying to find the area of the shaded region. So we have a big rectangle and then we have a little rectangle. So what we're trying to find is the area of the big rectangle with a hole missing out of it. So what we're going to do is we are basically going to take the big rectangle minus the small rectangle. That is the idea of what we're doing here. Now, area, don't forget, is length times width. So basically one side times the other side. So for this though, the biggest thing, and this is what messes so many people up, is we have to keep the big together minus the small together before we ever combine like terms. You're going to see what I mean by that in just one moment. So our big rectangle is going to be x plus 5 times x plus 5. And then we have minus our small rectangle, which is x minus 1 times x minus 3. So this is our setup so far. Now, like I was saying earlier, we need to keep the big together and then we need to keep the small together. And we're going to do that by putting big brackets here. Now, you're going to notice on this problem, we actually have to distribute twice or FOIL twice, table method twice, whatever it is that you're choosing to do here. So if we do that, first I have x times x is x squared. Outside, I have x times 5 would be plus 5x. Inside, I have another plus 5x. And then last, I have a plus 25. And again, I'm going to keep my brackets there, keeping that all together. Big minus sign here. And then we have x times x again would be x squared. Then I have outside would give me minus 3x, inside would give me a minus x, and then last would give me a plus 3. A lot of people put minus 4 on that one. Don't forget we're multiplying. It's negative 1 times negative 3, which would be positive 3. Then I'm going to keep those big brackets there. We're keeping the big separate from the small right now. I am not subtracting anything yet. Don't forget our next step is to combine like terms. Inside each of the brackets separately. So when I do that on my first big rectangle, I get x squared plus 10x plus 25. And we're still keeping those big brackets there. Big minus sign. Start my next bracket. I have x squared, negative 3x and negative x makes negative 4x. And then plus 3. Go ahead and close that bracket. Now there's nothing else I can do inside of the big rectangle and nothing else I can do inside of the small rectangle. So if you actually think about it, These problems look a lot like what we were doing in 10.1. When we have a subtraction sign here, remember we have to distribute that to the second parenthesis or the second bracket, if you will, and then that will let us start to combine our like terms. So I'm going to bring down the first parenthesis. Remember, the first parenthesis is never affected by that negative. And then if I distribute the negative, a negative times x squared would be minus x squared. A negative times negative 4x would make that a plus 4x. And then negative times 3 would give us minus 3. Then my last final step is to combine all of my like terms now. So technically we had to combine twice. We combined right here, and then we are also combining right here as well. I see x squared and negative x squared. Those cancel completely out. I would write nothing for that. I'm running out of room, so I'm going to put an equal sign and write it over here to the right. Then I see 10x and 4x makes 14x, and then 25 and negative 3 makes plus 21. Haha, no it doesn't. It makes 22. Then that would be our final answer, 14x plus 22. So again, just to recap that, we found the area of the big rectangle, and then we subtracted out the small rectangle's area, because again, that's a hole. You should be able to see my face through that hole if I was holding up a piece of paper in the front of the room. And then once we subtracted, we distributed that negative, combined like terms. That's our answer, 14x plus 22. Okay, last type of problem here. Now, you will see that we're going to multiply two polynomials together again. However, it's no longer a binomial times a binomial. It's actually, in this case, a binomial times a trinomial. So 2 terms times 3 terms. So you'll notice it says apply the same idea as 2 binomials, but just make sure you distribute through the trinomial. So the biggest thing I make sure I tell people when we do these problems is we can't FOIL here. Because if we do, first would give me this, outside would give me this, inside, and then last. Notice right here we completely missed that x term. So we can't actually say that we're foiling here. It doesn't follow those actual letters, but again, it is technically the same idea. So I'm going to go ahead and erase this really quick. We're going to take 6x and we're going to distribute that through the whole trinomial. So 6x times 2x squared would give us 12x cubed. 6x times x would give us plus 6x squared, and then 6x times 7 would give me plus 42x, and then we're going to take minus 8 here and distribute that through the trinomial all the way. So starting with 2x squared, I have negative 16x squared, or minus 16x squared. Negative 8 times x would give me a minus 8x here, and then negative 8 times 7 would give me a minus 56. After I distribute all the way through, again, like before, our last step here is to combine like terms, but also putting our answer in standard form. So I see a degree of 3 first, but I don't see anything else with a degree of 3, so I'm going to bring that down, 12x cubed. Then I see 2x squareds. When I combine them together, I get minus 10x squared. And then after that, I see 2x terms, so 42x and negative 8x makes plus 34x. And then that lonesome minus 56 is going to get brought down at the end, and that would be our final answer. Okay, same exact idea on number 13 here, taking 8x and distributing that all the way through. Actually, you know what? Let's do the table method on this one, just in case that is your favorite method. So I'm going to really quick make my own table. Let's see, I keep making it too small. There we go. So making a 3 by 3 here. I am doing this on purpose right now because we need to talk about this. Remember from the front of your notes, we don't put anything in that top left box. So I would put 8x here, minus 4 goes here, and then I'm going to have 6x squared and then 2x. So on the front, we only had to make a 3 by 3. However, since we have a trinomial here, you're going to actually add another row to your box here, and that then lets us add that plus 1 there. So then now we have to make sure we multiply everything all the way through. So when I do that, 6x squared times 8x is going to give me 48x cubed. 6x squared times negative 4 is going to give me minus 24x squared. Then we have 8x times 2x is 16x squared. Oh, by the way, I should have said this. If you don't want to do the table and you'd rather do it the way that we did it on number 12, feel free to do that right now. Just make sure you compare your answer with mine at the end and make sure you're good to go there. Going back to this though, 2x times negative 4 would give me minus 8x, and then 8x times 1 would give me 8x. Negative 4 times 1 would also give me negative 4. I'm going to move this down slightly. Okay, now again, have to put our answer in standard form, but then at the same time, we also have to make sure we're combining like terms. So I see that x cubed there. I'm going to bring that down, 48x cubed. It doesn't combine with anything else. But then I see this negative 24x squared and 16x squared. When I combine those together, that's going to give me a negative 8x squared. Then after that, I see a negative 8x and a positive 8x. Well, those add up to 0, so then that's actually going to cancel completely out. And then we're going to bring down that minus 4. This would be our final answer using the table method. If you wanted to do the distributive property method, you are more than welcome to. Just know that it takes up a lot of room horizontally. When you go to write it all the way out this direction, it's going to take up a lot of space. So completely up to you on what method you want to use. Again, if you like the table method, I have sheets of paper that have tables all over them that you can use. Or like I said, and like I just showed you on this problem, you can draw your own table. Completely up to you. But that is it for these notes.